recap, like 5 minutes for those people who were not able to make it during the first session. We'll talk a little bit on practical ways of reducing whole life carbon emissions, like what you should be looking at. So 15 minutes in total of showing some presentation slides, and then we will crack on with demo and exercises at the same time. So the plan is that from this point onwards, anything that you're able to do, feel free to do it at the same time as me, because in order to become familiar with the software. The Revit plugin, some of you might not have access, you might not have licenses, so that's right. But Excel import, I guess you all have licenses for Excel, so we can always just do that together. And then I have allocated some 15 minutes for Q&A. I will be taking the chat during the session to see if you have any questions and answering during the session. Yeah, and I think we are ready to start actually. So to recap, what is life cycle assessment? So what we're doing today. LCA is a standardized methodology to assess, estimate, calculate the environmental impacts of a product, system, or process throughout its entire life cycle. In our case, this product is a building. So we're looking into impacts from the raw materials extraction, the transportation to the factory, the actual process, the manufacturing process impacts, transportation to the construction site of those construction products now, any impacts from the construction process, like electricity and fuel used on site, the use dates with energy and water consumption, and any material related emissions, like emissions from replacement of materials, repair, and so on. The deconstruction of the building, which is the opposite of A5, again, electricity and any fuels consumed on site. The transportation of these waste materials now to the treatment facilities, the actual processes in those facilities, any emissions after any of those materials are disposed to a landfill. For example, if you have bio-based materials, that would be any methane emitted due to decomposition of these materials. And then we have module D, which is called the benefits and loads beyond the system boundary. And this is how we calculate actually the benefits from reusing and recycling materials at the end of life, or incinerating actually some of those materials to recover the energy. Why we do this? Let's go through this graph. This is from the emissions gap report from the United Nations Environment Programme from last year. So this blue line first, it shows where we are heading in terms of global carbon emissions rate in 2030. So this shows like we're going to around 60 gigatons of CO2 equivalent per year. This is where we will probably go if we achieve our current targets in the various countries we live in. And this is where we should get actually in less than 8 years from now, if we want to stay below, if we want to keep this goal alive actually. So this is more than a 50% reduction actually that is required, which is a lot of work we need to do in 8 years. And what it means for our industry, the construction industry, buildings are, as you have probably seen in other presentations and from other sources as well, it is responsible for 39% of the global carbon emissions, or if we split it between operational and embodied carbon emissions, 28% of those global carbon emissions is from buildings operation, and 11% is from their embodied carbon. On top of that, cities globally are expected to double by 2060, creating an additional 230 billion square meters of new spaces, in our cities, resulting in some 150 to 250 gigatons of embodied carbon. So what that means, actually, because all these numbers are quite huge, this is, oh, I didn't actually use that slide in this case, but just to give you, to make you actually visualize that, it means like building a new New York City every month or every 34 days until 2060. Another way actually to visualize exactly this concept is if we split, if we show the carbon emissions against time. So we've got carbon emissions here and the years during the life cycle of a building here. You see that we've got a big carbon emission at moment 0. This is the embodied carbon of the new construction materials, and the transportation of those materials and the actual construction process. And then we've got some equal amounts of carbon emissions every year for the next 60 years or so, and we'll have some embodied carbon every now and there. And this is from material replacement. Now, if we were to take into account the actual operational energy consumption, because the electricity grid in all countries will inevitably decarbonize at some point, and buildings will become more and more efficient. This graph will actually look something like that. So embodied carbon will be exactly the same because it is emissions that are happening now, but operational energy and other embodied carbon emissions actually during the life cycle of the building will reduce accordingly as the electricity grid decarbonizes, as the heating systems become more efficient, the sources becoming different, and as the manufacturing processes are also becoming more efficient in the future. So we can see here now that the significance actually of embodied carbon, which is the not embodied carbon, but embodied carbon at year 0 actually is becoming more significant because it now accounts to like 2/3 of the overall whole life carbon emissions compared to a 50-50 split or even lower that was previously. So that was just to recap what we said in more detail previously, and just a few slides actually on things to consider when you're trying to reduce the whole life carbon emissions in your projects. The first is to build for the verified need. I mean, this is the very first thing you need to consider. This links to material efficiency and space efficiency. So the more efficient your building is in terms of the function that it's going to serve, the lower the embodied carbon will also be. And this is probably the very first thing a design team will probably work and heavily affects the embodied carbon of the building. Next, because we're talking about whole life carbon emissions, we have the energy efficiency and renewable energy. Embodied carbon becomes more and more important, but this is because the energy efficiency continuously increases and renewable energy production also increases in buildings. So this should not be overlooked. I mean, it's one of the first things that you need to do as a sustainability consultant to make your building as efficient as possible and add as many renewables energy production as possible. So yeah, this is quite obvious, but I just wanted to highlight this as well. It's not that embodied carbon will basically become more important than operational energy. It's just that after you see after you make operational energy more and more efficient, embodied carbon is becomes more and more important as well. Then we've got recycled materials. So always try to use materials with recycled content. In the case of concrete, for example, that would be concrete mixes with recycled binders. In this case, that would be DGBS or PFA, which stands for fly ash. So the more, both of these are industrial byproducts. So the more you add them actually within your concrete mix, the better, as we can see from this graph right here with like 100% Portland cement mix, and how the embodied carbon is reducing as you increase basically the fly ash and CTBS content. Another example with bricks, just to showcase what it means actually to reuse materials if and when possible. In this case, we're having a common clay brick and a reclaimed brick, and you can see like a huge difference. It's almost like no impacts at all for the reclaimed brick. Some of them, for the deconstruction process and disassembly and transportation probably, but definitely much less than producing new bricks. Similarly with any steel or metal products as well. In this case, we're looking at reinforcement bars and what is the difference between an average rebar in European Union and this manufacturer that produces like 100% recycled content rebar, and you can see the big difference. Then we need to look into the lifespan, the life expectancy of the materials that we are specifying, that we are installing in our building. So the more durable a material, the less frequently we will need to replace it, which will result in less embodied carbon over time. And this is why it is important to look into the wider picture, not just in the materials that we add in the building during construction, but also what happens in 10, 20, or 30 years. So it's different to have like materials that will be there for 60 years and different to have materials that will have to be replaced in 40 years, for example, because this will result in additional manufacturing and additional transportation and additional end-of-life treatment for the replaced materials and so on. Renewable materials, it's what we call, it's how we call the timber and timber-based products. Obviously, there is a benefit in carbon storage for those materials because they sequester carbon, which, however, will be released at the end of life. But when you do that, you can also recover some energy, which will be offset from fossil fuels incineration. And even besides that, it's always better actually to use timber versus compared to steel or concrete. I think that's generally accepted, I believe. And then minimizing the material consumption. So that has to do with material efficiency. I mean, I have a very simple example here with a building with 2 basements, and then how they managed to reduce embodied carbon by simply excavating and having the basement actually exposed. So this way they reduce the amount of concrete from the retaining walls and so on. Other strategies like changing the construction method of the upper floor. So instead of concrete flat slabs, to go with bubble decks or composite decks or any other innovative construction method that would save you some material quantities. Things like reducing the floor to ceiling heights without this obviously compromising, the aesthetics and comfort within the building. Probably taking out ceilings and have exposed ceilings and so on. So there are plenty of things that you can look into during the design process. Then we've got the comparison between products and different manufacturers, which is also very, very significant. So after you have done all those things and you have identified the type of material that you want to install within your building, it's time to actually start looking into specific products, because you are at the stage that you need to specify those products as an architect or as an engineer, or actually specify and install them if you are in the contractor's side. So for the same material types, you will see that different products vary a lot in terms of embodied carbon, and this is because of excuse me, different manufacturing methods, probably different countries with different electricity grid, carbon factors, and so on. So there will be some significant changes in some cases. So it's always good to look into the best performing manufacturers, let's say. In this example, we're looking at some rebar steel emissions from various different manufacturers. We don't name any of them, so let's say that this is a qualitative example. And we compare basically some European manufacturers and some Asian manufacturers to show how the location also plays a significant role. Then, other than the material itself and the manufacturing method, we should also be looking at transportation and where this material is coming from, construction in terms of construction waste. I mean, there's not much you can do during the design stage, but you can always set targets. You can always specify some prefabricated elements, which means that you will reduce the waste, and then for the end of life of the building, there are things that you can look into, like the recyclability of the materials that you have specified, if this material can be recycled, or if it can be reused, and if you can basically, with any ways, avoid landfilling those materials. That will make a big difference at the end of life impacts. So yeah, a list on, for during design, just basically a summary: optimize material efficiency, consider the installation and dismantling of the product, consider carbon sinks, that relates to timber-based products, track the emissions during different life cycle stages, and this relates to the lifespan of the various materials, and find and assess alternatives of the most carbon intensive products, which relates to the different manufacturers. Then for construction and procurement, which might not be as relevant for this content, I guess, but still important to mention, use existing and recycled materials where possible, because again, I mean, you can still specify it if you have this kind of knowledge, but this is usually something that the contractor will assess when they start the works on site. Recyclable materials, again, for a contractor, they can also do that, use recycled materials. Prefer manufacturers, because that's also on the contractor's side many times. They are the ones that they will have to find the exact product based on the designer's specifications. And yeah, again, prefer green manufacturers where possible, actually. That was it, actually, in terms of theory. That was all, and I think we should start doing some demos and exercises. I don't know, Eric, if you managed to send the exercises for today. If not, that's still okay. Yep.
You want me to send the PowerPoint presentation? Because I've shared already exercises on Monday, but you want some other ones?
Yes, yeah, that's a new one actually. It's exercises for the second lecture. I sent it. It's my bad because I sent it like a few minutes before the session,
Okay.
but that's fine. We can always just check my screen and do it together actually. Eric had previously shared with you the first 3 exercises together with some guidelines on how to create your account and how to create your first project. So I will take for granted that you have created your accounts and you have managed to use the license key to create your first project. If you have any issues with that, feel free to write it down to the chat and we can check it together. But for now, I think I'm gonna skip this part and actually try to start from scratch actually and create a new design. So if you have not managed to do it yet to create your first project, keep your eyes on the screen and try to follow the same steps. So I'm gonna add a new project, a building project. In your case, it will probably say LCA trial or something like that. I will click on that. I will ignore the licensing thing because this is not, you're using a license key instead of a proper license. So I'll just leave it empty and I'm gonna call it Saint-Gobain demo. And let's say that this is an apartment building because that's student accommodation. So that should be the closest months. Yep, and the country is Poland. I'll wait a few seconds actually for everyone to do it. Remember to leave the license empty. You don't need to add anything in there. And I will click on next. These fields are optional. You don't need to add them. But yeah, let's just add something in this case. I think based on some basic calculations, I think the overall size of the building should be around 3,500 square meters in your case. So let's just say that probably number of floors, I would say it should be around 3, I guess. But you probably know better. I didn't look in the documentation properly, to be honest with you. The frame type, we don't know that yet because we're just now starting our project. And I will leave the certifications pursued empty because, yeah, I don't think there is a requirement for that. So once I have added the cross floor area, I will click on next. And I will get this screen, which is basically my project, but I get this message here that I don't have a license yet. Do not use the OneClick LCA Planetary because that is a free version of OneClick LCA, which obviously has some limited functionalities. So it's not what we want you to use for this project. Don't start a free trial because again, it will be for a limited amount of time. Obviously, don't try to buy a license because we have already given you some licenses. You don't have a license to select, so the only thing that remains is the enter license key. So in this case, you should be able to, you should have received actually a license key from your university's teacher. So we have sent this license key to at least one teacher from each participating university, and then this license key, this teacher actually should have forwarded this license key to the students. So in my case, I'm going to use another license key just to show you how to do it, and activate the license. And then this is what you should be able to see in your in this project. Again, it looks quite empty. and this is because we have not actually added any designs yet. So remember that this is a project, it's not your actual design. In one project, you can have several different design or several different options, as you might want to call them. So as the software highlights, you need to get started. So click on the get started icon, and it will prompt you to name your first design. In this case, let's try to make a baseline design. And that's all of it, really. That's all you need to do. The concept states it should be the same. Actually, in your case, I believe it might ask you first what tool you want to use. I can't remember if we only have the levels tool. If that is the case, you might just get the same screen as me. I think that will be the case most probably. So I'm gonna say that this is concept design. It's not gonna affect the results. It's mostly for you to keep track of where you are at this project. So if you have just started, obviously it is concept design. The predefined scope, we can leave it as levels EU because that is going to include everything: foundations, envelopes, structural frame, finishes, and services as well. So all you need to do really is to name your first design. I'm gonna click next. And in this case, I am not going to review and adjust the LCA parameters. I believe that we did check this in the previous session, so I would prefer not to spend more time in this session for that. I'm going to use the default LCA parameters in this case. And here we are, we've got our first project with our first design option. And at this point, I think I'm going to check the chat if there are any questions. There is
just in case you haven't got your license key, so do not hesitate to say it in the chat or contact your Saint-Gobain local contact if needed, saying your university, of course. Otherwise, it will be hard to check. Thank you.
Okay, because we have sent like the license key to one university, so we will have to cross check with who is. It might be that your teacher might have not sent it to you yet, but yeah, feel free to do that, and we will take care of that. So we are at the project level now, so we are going to. I think we are in the third exercise. We're gonna skip the manual modeling because we saw that in the first session, and you should have. I mean, if you wanted, you should probably have completed the exercises as well. So we'll just go to exercise 4 directly, which is a carbon designer. So carbon designer is a tool actually that will create a whole life cycle of a full building by just adding some very, very basic information like the total gross floor area, the number of floors, and that's it, and the type of the building, of course. And it will create an estimate of around how much it will be its embodied carbon. So we're going to do that. This tool is ideal actually for early stages where you don't have any design yet, but you still need to have an idea of where your emissions are in order to start looking into improvement strategies and so on, and comparing different material types and different products and so on. So we're going to show that now. So I think we don't really need to follow the exact exercise, but I'll just go through, do some small breaks to make sure that you're following up. So if you click on input data, you see that similar with last time, there are several items here that are missing. In this case, we will just ignore everything and go directly to the Carbon Designer Create baseline. We're going to click on that, and this will take us directly to another user interface, which is this one. This is the Carbon Designer interface. You still have the path of where you are, which is your project name, your design option name, and then it says that you're working on Carbon Designer now. So in this case, I'm going to leave. This is all you need to know, actually. This is the scope of your assessment, the element scope of your assessment, which building parts you want to include. So we're going to include everything in this case. Then let's say the methodology with which we're going to estimate these building material quantities. There's not a different methodology in each country, but in some of them and in most others, actually, we've got the international reference building, which is what we will need to use in this case. So we're going to select that. And then we've got the apartment buildings as a building type. The total gross floor area, it has already read it together with a number of above ground floors. You can always change that if you want. The calculation period, we're going to set it to 60 years because that is quite a common practice in European standards. And then in the more options, we can say that we have one underground unheated floor. It's up to you, actually, I guess, if you want to do something like that. But because I don't know what will most probably be your design, I will just add it in this case. I guess earthquake is not an issue in Poland, so you can basically ignore that. But if it was, you could click on any of those buttons, and this will actually adjust the structural quantities because higher seismicity will result in larger concrete and steel and any other structural material quantities. But we can let it as is for now. The required foundation type and depth. Again, if that is known, you can make an assumption on what will be the type of the foundation. If it is a very soft soil, you may want to go with steel core piles or concrete piles and so on. Otherwise, footing foundations for hard soils and so on. If you have no idea what it is, you can always just leave it and it will make an average, a typical assumption, let's say. Then on the scenarios part, where it says baseline scenario, I am going to choose the concrete in situ because I know that this is like a baseline scenario in pretty much every country. I mean, this is a typical construction method everywhere, really. So I'm gonna say that. And I don't need to do any comparison yet. So I am going to click on calculate areas and give you a few seconds actually to make sure that you manage to do the same thing as me. All right, so once you have calculated the areas, you will see on this part of your screen that you have the building dimensions, which is what the Carbon Designer estimated as a typical building for these values, for this gross floor area and this number of floors. So it basically assumes a rectangular shape. If in your case, if you have already started your project and you know some kind of dimensions, you can always change it, like the overall height, the width, the depth, the internal floor height. You could change it to 3 meters if you want. Any of those values can be changed. So yeah, just to be able to change something, let's change the internal floor height to 3 meters. And then there is a SAPE efficiency factor, which will basically try to, it will actually change the material quantities from, a perfectly rectangular shape to something more complicated. So with this one, we account for non-perfectly rectangular shapes, which is quite common actually not to be perfectly rectangular. So that means we will apply 10% actually increase in those material quantities. And then on this side, we've got the different building parts, like the foundation, cleanliness layer, ground slabs, floor slabs, and so on. You can see all of them have their own units. If you know any of them, if you have a more accurate estimation, you can always change that. You can hover over to see what is the description of each one of them and what you are supposed to add in those ones. I think, let me check actually the exercise to see if there's anything else we could possibly change. Yeah, so yeah, that's a good one. So if we go back here and load-bearing internal walls, we could say that we will most probably also need like 15% of the internal walls being load-bearing. Probably this is more relevant for bigger buildings where you have like concrete cores every now and then. So you can change that one as well, and we could also probably change this one to something higher, like 1.2. So this has to do about accuracy, which in early stages is not the most important thing you need to worry about, because the most important thing is to get a baseline, regardless how accurate it is, because in that case you will not then be able to start playing around with different material types and different products and see what each change means actually in terms of reducing the embodied carbon. And then once you get more information, you can start making your design more and more accurate. And as the design progresses, you will be making your results as well more accurate. Let me close that. So I think I'm not gonna change any other thing here. And what I have to do then is to create a baseline. So this will take some time because it's basically trying to estimate the material quantities from the different building parts. It will find automatically a suitable mapping and then do the calculations. So it usually takes like half a minute or something. So we'll have to wait. In the meantime, I see that many of you, some of you actually don't. You say that you don't have a license yet. So what we're going to do about that is we will check the university name to see if we have sent it to any teacher from that university. And if that is the case, we can send them a reminder, Eric, to send the license key to their students, I guess. But if we see that we have not included it there, we will need to find a contact from that university, I guess. You're muted, sorry.
No, I was just checking in the list and answering directly in the chat to which teacher the license key has been sent.
All right.
Normally.
Okay, that's great. Okay. So if you're doing that, that's great. Thank you. And yeah, so we've got now our results in Carbon Designer. So you see that we've got a graph with a bar with different bars for different building parts. That shows us actually the absolute number of tons of CO2. And then we've got all these different subcategories at the bottom. You can expand any of them, like external walls, for example. you see here that the assumption for a typical building is that it's going to be in situ concrete wall with mineral wool insulation and so on. There's another one for cladding and windows, externals. You can actually access all of those. So what you are supposed to do here now in Carbon Designer is actually do a first kind of hotspot analysis. So what I would do is to see and identify which parts of the building result in the highest carbon emissions and see what I can change in those cases. So I see the highest is the floor slabs. These are the ones that contribute the most. So let's go together to the upper floors, floor slabs actually, and see what is the assumption. So if we expand that, we see, because we said that the baseline is a concrete in situ design, we get in situ concrete slabs assembly. It doesn't say what is the thickness in this case. It only mentions like the total area of those slabs. But if we click on the edit button, it will also give us like the thickness. In this case, I cannot see it because I have a plugin in my browser, but it's 240 millimeters of concrete and then some additional reinforcement. You can always change the thickness if you think that is probably too much for a building like this, just to make it more accurate. But the purpose of this exercise is actually to look into different materials or different types of this element. So if I click on the drop-down list, I will see what other options I have available for this element. You will see that it's relatively limited. Again, this is because we are at a very early stage. We're not looking into, many different ways and more detailed ways actually to change this. So we've got hollow core slabs, we've got wooden joint floor assembly, CLT floors, composite decking, steel, again some CLT slabs, and hollow clay bricks floor slab assembly. This case, I would probably try something. I mean, I could go with CLT to see what will be the difference, but I will do it step by step and do something more realistic, like the hollow core slabs. So these are slabs that are not like solid, like regular concrete slabs, but they have hollow cores just in order to reduce the amount of concrete, but still offering the same, let's say, function, which is supporting the loads above. So I'm going to select that, and this will take a few seconds to recalculate, and we will see here now that we have another set of results right next to the original ones. In the building parts that nothing has changed, these bars will be gray. In floor slabs, we have a reduction, so it shows it as green. If this will result in an increase, it will become red. I mean, it's that simple at this stage. Something else we can change is probably ground slabs. I don't think there is a lot of room to improve that because it is concrete, but I will leave this to you actually to use your imagination on what you can do there. Roof slabs, internal walls, we could have a look at the internal walls as well. So you see here that we have an assumption that 83% will be steel stud internal walls, 70% will be doors, which is a fair assumption. So what we can change actually is this number here. And we are working with percentages in Carbon Designer, again, because we are at a very early stage and it doesn't really make sense to calculate absolute numbers and so on. So we are not supposed to know the exact numbers when we are using the Carbon Designer and when we are at this early stage. So just in order to demonstrate this, I'm going to use timber studs instead. like 83%, and I will have to reduce this to 0. And if we go back on the top, we will see that there is a difference here as well. There is a small reduction in the internal walls, and we can keep doing that actually for all other building parts. I'm not going to do it for all of them because we need to keep some time for everything else. So I will give you a few more seconds actually to, just in case you are a little bit behind, to make sure that you do the same changes as me. And then actually I'll need to consult my slides. Yeah, so we did that. Yeah, so in this case, I wanted to show you this feature right here on the top, the apply scenario feature. So in this case, let's say that we changed our minds and we want to discard all those changes. So what I am going to do is to restart my design, and this will take me back to the input page in the first page of Carbon Designer. I will do this very quickly, like 60 years is what we are missing, and then the one basement floor. The baseline scenario, again, I'm gonna set it up to concrete in situ, and I am going to calculate the areas. I don't really remember what we changed at that time, but we don't need to change anything now. I will just very quickly create a new baseline. Let me check that to see if there are any questions. Okay, I think I see most of the comments are on licenses. And yeah, I see Eric is handling it. So yeah, a few more seconds. And it should be ready. Yeah, I just had to take some time to do all the work. Okay, there we are. So we've got a new fresh baseline. So what I'm gonna do now is I'm not gonna go through the subcategories individually, but in this case, we have the option to check into 4 different options in terms of the structural frame, because that usually makes the biggest difference. So in this case, we start with concrete in situ. Let's see what it would mean. I mean, I'm not going to change. I'm not going to check all of them, but I will just straight away go to wood just to see, you know, how this would change almost all building parts, or at least, yeah, the ones that are contributing the most. And this will take some additional few seconds. And then we should be able actually to send this data back to the main OneClick LCA application and keep updating the model from there. So yeah, there we are. So you can see that there is a big drop in the floor slabs and the external walls and the roof slabs. There is some slight increase in the roofs, which is basically the roofing materials on top of the structural slab, probably because of some additional protection in that element, and so on. So at this point, let's assume actually that we are happy with what we have done in the Carbon Designer. So we scroll down to the bottom and say Save Design to Query. And this now will basically transfer everything to the main application. And there we are. So for those who were present in the first session, you probably are quite familiar with this page now. But very quickly, it's basically 1, 2, 3, 4, 5, 6 different parts. These parts represent different building parts, like the foundations, the vertical structures, and so on. So you see now that in most cases, these are actually constructions. They are not simple materials, and I believe that we didn't manage to cover the constructions actually in the previous session. So I guess that is actually a good pass actually to check those. Adding materials is probably the most common way of creating an LCA model in OneClick LCA, but we are also allowing our users to use what we call constructions. So constructions are basically a group of materials that represent a specific building element. In this case, you will see that there is something which is called like a timber frame, external wall assembly, including mineral wool insulation, blah, blah, blah. So if I click on that, you see that it expands and it shows me all the different materials that make this wall type. So it is a gypsum plasterboard, it is timber, glass wool insulation. Probably this is for the timber studs. Some extra timber for the timber studs, glass wool insulation, and then another layer of plasterboard. So by that, whenever I change this quantity, let's change it to 1,000 square meters, it will automatically update all the other material quantities. So I think this is a very useful feature actually for early stages where you don't want to spend time on looking, what are the individual materials in that external wall or that partition wall and that upper floor and roof and so on. You can just go and use the constructions, and this will do the work for you. In order to find constructions, if you don't use the Carbon Designer and go directly to the main application, you can use the material filter and go to the constructions and say that we want to use to find an external wall construction. You can go to the appropriate part. I mean, that's optional. You can place it everywhere, but for housekeeping reasons, please make sure that you add it in the right category. And let's look for something that has bricks in it and is an external wall construction. So in this case, we can use a brick sandwich wall assembly, including mineral wool, or any other actually that is available here. So I'm going to just use that just to see, to show you how it looks like. It's just another new construction. Excuse me. I will add another 1,000 square meters of that. And that is it. You can see now all the different materials that make this construction. Since we are in the constructions, you can also, there is something that we call branded constructions. And these are basically solutions that are created and published by manufacturers who want actually to not just give you the option of using their product as an EPD in your building LCA, but also give you like the entire structure of that element that will include their product. In this case, Saint-Gobain have several sets constructions. So what you can do is, again, use the constructions as a filter just in order to get only relevant results. And you can type Saint-Gobain, and you will type yeah, there we are. And you should be able to actually, I removed the filter because I think that is actually results in this error. And then you should go actually to either any of those categories actually that represents a construction. So in this case, we've got external thermal insulation composite systems, or I'm not sure. Yes, suspended ceiling systems. We should be able to get some branded constructions there as well. But yeah, let's actually check some internal wall constructions. Actually, we should be able to see, and you can. Yes, you can identify the branded constructions from the brand, from the logo of that brand. Yeah, that was my bad. Actually, it looks like that the manufacturer name is not working for the construction. It's definitely working for EPDs when you're trying to find EPDs from that manufacturer, but not in the case of the constructions. But if you open the entire category, in this case, let's say that we're looking for internal walls, you will see that there are several branded constructions, and as I said, you can identify them from the logo of the manufacturer. So you can actually use any of them. You can basically add any of them in your project, and you will be able to expand it and see that should actually be yeah, the exact EPD that is being used. You can add like an extra 1000 square meter. And yeah, yeah, I would recommend that actually you, whenever you are trying to find a suitable construction, you can probably select the exact element that you want to go with, and see if there are any branded constructions. These constructions should be quite accurate because they are created by manufacturers. So you will basically be able to save the time from, finding out what kind of layers you will need to add. Obviously, if the thickness of some of those layers is not suitable, you can always open that construction and change it. Yeah, like that one, for example, you can change. In this case, everything is modeled on a mass basis, so you can always just change these numbers. You'll get a notification that if you change it, it will not update every time you change the main quantity, but that's fine. Or you can actually change the unit as well. So give me 1 sec actually to check my slides. Yeah, so we did save the design to query. So I think it's time now actually to start doing some EPD comparison. Or actually before that, I think it would be better to show you how to replace the material. So one thing is to get a baseline design, but then you'll need to start actually make some changes, change the material types or change the manufacturer and so on. So in every material, you're able to go here and click change and click on replace, and then change this to anything really. You can type here anything. In the case of construction, that is not a branded one, just to show you how you could do it. So let's say that we want to change this plasterboard because we identified a specific product that performs better than the average. And I want to remind you actually how you can check this. So when you're searching or when you have your materials in the materials page, you will always get a question mark icon right next to the material name. So if you click on that, you will get the data card. The data card has several different sections, like description, which gives you like a brief description of what this is about, some other technical characteristics like the default thickness, the available units, and stuff like that. And then we've got the environmental profile. So in here, you will see the A1 to A3 impacts, which are basically the manufacturing impacts of that product in all the different available units for that data point. So we can see here that in this case, this is 0.29 kilograms of CO2 equivalent per kilogram of this plasterboard. And let's actually try to change that. Now, because this is in a construction, inside the construction, it's not as straightforward to replace it as it would be like with a material that it is a standalone material in the model. You could just go to change and replace it and just type your new material here, and that would make the work. But because it is in a construction, you will either have to unbundle the construction, or you can actually just set these to 0, which depending on how tidy you want your model, you have to decide. In this case, I will just do that actually. So I am going to set this to 0, and then just, look for a Saint-Gobain product. So you can write the manufacturer name that you're looking for, and then see what subtypes, what product types they have EPDs for. So in this case, I'm looking for a regular gypsum board, and it looks like there is a product that is being manufactured in Poland and has an EPD, which is that. So as a priority, you'll always get the local manufacturer specific data when you search for anything, and then regional generic data and regional manufacturer data as well. So I'm gonna use that one from Saint-Gobain and add like 1,000 square meters, and these will actually do the work. So I'm gonna save, and these will recalculate the impacts and so show them in this preview column. So we were at, sorry, look at internal walls, I think. Sorry, I got lost suddenly. Come on. Apologies for that. Let me very quickly find it. Why cannot I find it actually? I added like 1,000 square meters of that, so I should be able to find that. Oh yeah, it says something went wrong and it wasn't able actually to update it. Okay, that might have happened in this case. Let me check my connection if you're still here, actually, because that should be, yeah, it looks like connection is okay. So I'll just try to do it again, actually. So we were looking into this one. We had changed that to 0. And then we were looking for a Saint-Gobain gypsum board. So regular gypsum board. Then add that for an additional features. And I'm gonna try and save it. Okay, and it looks like we managed to update it now. And it should be somewhere here. Okay. Yep, there we are. So this is how you can do it. You can always unbundle things as well and bundle them again in in new constructions. So what we are going to do now is to see how you can actually compare different EPDs. Let me just double check the agenda, just make sure that we don't lose track of time. So we had allocated some 65 minutes. I think we are on track, so we're gonna show that and then proceed with Revit. So back to the exercises. Okay, there we are. So what we can actually do is to start adding some stuff in the so there are several different ways actually to compare different products. One is the compare data feature. So what you can do is start adding, materials in the compare feature, and I think we added that one as well, and that. And when you are happy with the materials that you want to compare, you can click on the compare data and get a graph actually that compares the different products. In this case, this is not a valid comparison because the main unit for one material was set to be 1 kilo, and the main unit for the other material was set to be the 1 square meter. So it's not a feature that can work all the times because it really depends on the main unit. Well, let's give me just a few seconds. But it's still something that you can use within OneClick LCA. So we're gonna skip that actually and go straight to how to directly compare different materials within the model. So I'm gonna go back to the project, input data, go to building materials, and basically just start adding materials with the same quantity and get a benefit of this result preview feature here. So I've got this slide right here where I'm saying we will need to add these 3 different gypsum boards and check the results. So I will start doing this one by one, and you can follow me if you want and do the same thing. So I'm going to go to the internal walls and look for a Saint-Gobain gypsum board, which is that one. So I'm going to add that, and I am also going to add, so these are special gypsum boards. They are not regular ones. They are all fire resistant. So this is something that you need to take care, so that when you compare different products, you need to make sure that you compare equivalent products that serve exactly the same functions. Otherwise, it will not be a valid comparison. So third one, and I'm gonna add like 1,000 square meters for it, and go and save. And we see that it now calculates, so you can actually then check the preview. Yeah, we were here, the preview, to see which product actually performs better. You can get the absolute value, but also you can get the relevant in the overall results. So next exercise, yeah, is the performance ranking feature, which I didn't show. So what we are going to do is, let's say that we are looking at this generic floor screed material, which I believe is from a German database. So I'm gonna add that material to my design. So we're gonna start like with that one. And probably open the data card. So when you go to the environmental profile, you get like the impacts per unit, per kilogram, per cubic meter, or per square meter, and so on. But at the same time, you get a performance ranking. This feature actually might not be available in your case, because it is an expert feature actually, which is it goes together with named users, in which case you're not a named user, but you're just using a license key that you have been provided. Yeah, so if you're not able to see the performance ranking feature, don't be alarmed. That's normal, and unfortunately, we are not able to add it in your licenses, because it will be impossible technically to do that. But I think I will still show that for those of you that already have a OneClick LCA account, a OneClick LCA license, and just be aware how you can actually use that. So by clicking on the performance ranking, I'm going to get, normally I will get 3 different bars in this graph, one with a project country, one with the neighboring countries, and one with all other countries. So in this case, because I have just 2, it means that in Poland, it seems like we don't have any manufacturers actually creating EPDs for this product type, which is mortars. So in this case, we will have to look in the neighboring countries. What I'm going to do is to set the average as a benchmark, and then say I want to see everything that performs 50% better than my benchmark from the neighboring countries, because there's nothing in that specific country, unfortunately. So I'm gonna click on show products, and then you get a list of all the different products actually here, and some were quite close to the top. We also get, I see this one from Saint-Gobain, but yeah, you can keep actually looking for the rest of the list. So remember that this is 50% better than the average actually. So we're basically talking for, on the top 25% of all available products. So depending on the product type, really, you will get like a shorter or a longer list available products. So in that case, if you identify, let's say, the Saint-Gobain product, you can click on that and copy the name and go back and say, you know what, from the comparison that I did, I think I'm going to use that product, and add it here and add the actual quantity. So I think that was it with the EPD comparison again. And I think the next exercise is Excel import. But before the Excel import, I think I'm going to show you the Revit integration, because I guess that many of you, if not most of you, will probably have a free Autodesk account, student account. So you can download Revit for free, actually, the education version of Revit. So then, yeah, I'm gonna go to Revit, and oh yeah, actually, how to install Revit. I think that's quite useful. As I showed last time, you have your help button here, and you're able to search for anything. So search for Revit integration. It will open up in a new tab with some guidelines on how to use it and how to install it, and the actual installation file at the very bottom of the page. We are about to release a new version, so by the time you install it, it might have changed slightly from what I'm going to show today, but the main functionalities will be pretty much the same, and of course quite improved, really. So back to the Revit window. You will see that there will be a separate tab on the top of your window, which is called OneClick LCA, and then there will be two different options. One is called LCA in Cloud, and the other one is called LCA in Revit. What the LCA in Cloud option will do is basically get everything from your model, all the different materials, and just send it to your account without any filtering, without any mapping whatsoever, and then you do everything else in your account. So let's try and do that actually now. It will ask me to log in. So first you need to define the project that you want to import those quantities in. But I need to find it. Yeah, I think I will just go with that so that we don't spend too much time trying to find the right one. So you select the project, then you define the design option that you want to import it in. In this case, I have several design options here. We can always say, add it in a new design, which is what we're gonna do, or actually just save time. We can just import it to something that I have already renamed to Revit import. choose the tool. In your case, it will always be the Levels LCA tool. And this has to do with the available tools and which ones you have added. As we explained in the previous session, you can add as many tools as you want, depending on the certification that you're actually looking for. So if you have if you want to achieve BREEAM and LEED compliance and levels compliance at the same time, you will have to use 3 different tools, because each one is tailored actually for the requirements of each certification. Filtering settings, let's us go with all data. There are some other options like structure and envelope only, or building with no systems or openings, and several others. In this case, I will just say all data, and anything I don't like, I can always just delete it later on. And then you will have an option to either replace the existing data, add on top of the existing data, or update the quantities from the previous import. In this case, I will just select replace existing data because I can't remember what I have in that example project. Before you do that, actually, you can always download the Excel, so that will actually show you the material quantities you got from Revit in an Excel format. And it's opening up in my other screen, so I'll let it open and bring it to the main one. There we are. So you see now that there are several different columns, like the class, the material, which is probably the most important one. So the material name, the quantity, and the type. This is as a minimum, the minimum actually that you need to have in order to import these quantities in OneClick LCA, the thickness of that material, and then some other quantities in both metric and imperial systems, depending where you are working from. The category, the Revit category, the family name, and the type name are also quite useful. And then by doing this, actually, you're able to review the information you got from Revit. You're able to change it if it's not suitable. In cases like that, for example, where you get a material name which is called default, because this is how it was named in Revit itself. So you can do you can check the drawings, you can check with your colleagues and say, that this is like a suspended ceiling or something like that. So you can basically redefine that material, something that makes sense to you when you are at the import process, and it will help you actually find a suitable mapping. So this is what the kind of things that you need to do here. Also, you can add new rows if there are some materials that are not included in your Revit model. You can always just add them here. And then once it's ready, instead of a Revit import, you do actually an Excel import, which is this Excel that was generated from Revit. And we will see how to do that in a little bit. But I'm gonna close that for now and just proceed with the Revit import in this case. So I'm gonna say continue. It will give you a warning that you're going to override things. I'm happy with that. And then at this stage, actually, is where it asks you whether you want to group some of those materials or not. In this case, you get in this stage, actually, you get all the parameter names that you got from the Revit materials, like the class, the quantity type, which is basically the unit you got for those materials, whether it is a composite element or not. We can always take this out, actually, the type name, the material name, and some others. And basically, you can select any of those parameters as the rule with which actually you are going to group those materials. So this means, in this case, that any material that has exactly the same material name It has the same type name, the same unit, and the same class. And the thickness, it doesn't differ more than 25 millimeters, for example, from each other. You can make them a group. In this case, I'll just unselect those ones because I don't think it's quite needed. But still, we don't get enough groups, and this is because this is a quite small project that I am doing, but we still get like one group of materials. So I am going to actually, if I unselect probably the type, we should be able to get some more materials. So that means that the same material from several types, from several categories are now able to group with each other. But yeah, this is definitely not something that you don't want to do really. It's good practice actually to split the model into by family type name, let's say. So when you're happy with the grouping you did, you can go to the next step. That usually takes a few seconds because it basically tries to do all this grouping, which, yeah, although in our case it's not that much anyways. In the meantime, I am going to check the chat if there is any question. Okay. It's all about licenses, and there is a comment in the language that unfortunately I cannot understand. If this is an important question or comment, please do write it again in English. So at this step, actually, we've got all the materials actually grouped into two different groups: the identified data and the unidentified or problematic data. In the identified data, you will see we've got the material name from Revit, we've got the class, which is basically the Revit category translated into something that we call a class in OneClick LCA, because we need to be as flexible as possible with all imported data from other software. In the comment, you will get the family name, so you get an idea of what it is. And then the actual quantity, you can always change it to another unit like volume. And then in the identified data, you get actually the resource name of the actual data point that has been automatically mapped with that material. So in this case, it looks like you can always click on the question mark to see what it is. It seems like we've got this data point from a concrete plant assigned to this. And then it tells you actually why it did this mapping. And this is because a colleague of mine in the past did exactly the same mapping. So the software learns actually from you and from your colleagues. If you change that, then in the next time it will remember your selection, and instead of colleague mapping, it will say your mapping, like it says here. So in the case of wood stud layer, it remembers that previously I mapped it with something which is like wooden frameworks from software and so on. So the more you use the software, actually, let's say the smarter it becomes when it comes to automated mappings. So I would suggest that most probably when you do your first import, you will not you will get quite few mappings, or the mappings that you will get will be from global users or users in the same country, depending on where you are based on. So you will probably have to review them and change them if you think they're not appropriate. But the next time you do the same thing, it will remember your mapping, so you will save a significant amount of time. At the problematic data now, or unidentified data, you get a list of materials that have not been identified. Actually, before I go to that, just to show you how you can actually change any of those materials, you can just click on those, select everything in the field, delete it, and look for any other door data point. You can choose from the entire database, and that will actually give you several more available data points. So we can go to that and select any of those things that are more suitable. To the problematic data now, you will see that this column is now not filled in, and this is because the software was not able to find a suitable mapping. So what you will have to do is read the material name, check the background data, anything that was imported from Revit. It's all shown by clicking this icon, this page icon in a pop-up window. So it will give you the class, the material name, all the different quantities in both units in this case, and then the category, the family name, and the type name as well. So based on that, you can make an assumption of what this is. If this is difficult actually to understand what it is, you can write, actually copy the type name and go back to your Revit model and try to find it really, and see visually actually what this is. Well, in this case, I mean, it's quite obvious, but I just want to show you a workflow really that you can follow. So you can select it and see where in the model it is, and you can do several other filterings, which you might know better than me if you're using Revit. So I'm going back to OneClick LCA. So you will have to do the mappings here. Obviously, there will be several different items here.
Marius, we have just one question in the chat. Instead of using Revit, can we use Archican to associate with OneClick LCA?
Yes, you can use it up to a certain version. Unfortunately, we stopped supporting ArchiCAD from. I'm not familiar with the ArchiCAD versions, to be honest with you, but I think it's a couple of years now that we stopped creating new plugins. There is a plan to do it next year, but for now, if you have an older version of ArchiCAD, you can definitely do it. If not, there is a workaround that you can use, which is exporting the materials in Excel. I think there is a good feature in ArchiCAD for doing that, and then importing them in Excel. And I'm pretty sure that you can read actually about this on our help center. So if you ArchiCAD, you will see about you'll be able to read more about ArchiCAD integration. And you can read it through. Unfortunately, I'm not quite familiar with ArchiCAD myself. Or actually, as I saw here, you can use a Trimble, the Trimble Connect integration, which I remember that it has like a free version of the software. So that is actually a BIM management tool, an online BIM management tool. So you can export an IFC file or directly import the ArchiCAD model, and it will read the materials, and then we will read the materials from Trimble Connect. There's definitely a free version, I think, for up to one project. maintaining at the time, so you can have a look at that. Yep, so obviously there will be a few elements, few materials that are not relevant, like in this case, like things called like black glass and juice and daisies and stuff like that. So you can always delete those ones. Or if you think that all of them are irrelevant, we've got this feature here that will delete everything that has a volume of lower than 0.1% of the overall volume, which is quite useful. I mean, it will not affect your results significantly. I mean, it will probably not affect it at all. So you can always just do that and focus on the bigger items. And in this case, it looks like these are non-relevant as well. So I'm just going to delete them. And once you're happy with that, you can click on the continue button, and this should take you directly to the results. Okay, there we are. So obviously, when you import something from Revit, you will most probably have to go back because no Revit model and no BIM model actually is, perfectly model and suitable for for an LCA like 100%. So you will most probably need to go back to the building materials and in some cases probably adjust some quantities or add other materials that are not included in the Revit model, and so on. So you can go back and you will see that it is organized exactly the same way as you do it manually. So it adds all the relevant foundation materials in the foundation part and the walls in the walls part and so on. And at this point, I think I'm going to show you the Excel import process as well for everyone that do not use Revit. So I will start actually with finding the template because the import process, the import from Excel is done using a template. So you need to use a template that is recognized by OneClick LCA. So to find that, you can go to the Help Center and type Excel. You'll see several articles, one of them being the import from Excel file. Feel free to do that at the same time as me, by the way. And at this article, you can read more about it, but I think it's better to actually show you. If you go to the bottom of this page, there are several different templates. I am going to use the building metric one. Depending on your location and the system that you are familiar, you might want to use the imperial one. But in this case, I'm going to go with the metric one. So it's just an Excel file that is downloaded directly to your computer. I am also going to open this up just to show you how it looks like. And it looks quite similar with the Excel file actually that we downloaded from the Revit import workflow, if you remember it. So we will again have the class name, the material name, the quantity, the unit, the thickness, but we will also have some extra, some additional parameters like the transportation, the comments, and so on. Not all of them are needed, so you can definitely delete some of them. For example, you can delete the transport because I guess it will be too time consuming for you to check where its material is coming from. So you can let the software actually apply the default values for that. So you can delete that. I would leave the comment because it's always a good practice to write some comments just for you to remember if you need to revisit, to remember what this material is about and where in the building it is being placed. And then from this point onwards, this is mostly about different classification systems used in several different countries, in several different tools, sorry. In this case, we're using the levels tool, So first of all, you need to define the language because this is available in 3 different languages. Probably you're going to go with English, and then you need to define the classification code for each material. So you can go with any of those options. So what I'm going to do is actually delete everything else. I mean, even the language is not really needed once you have defined it at least. So I will delete all those columns so that I have a much simpler file actually to work on now. So you see that there are some materials already added because we want this file actually to work as a sample file, so you can test it as well. Obviously, in your case, you will need to delete all those materials and start over with your own ones. But in this case, let's just use that. So I'm going to save that and close it, and then go back to OneClick LCA. Go back to our project, actually, the Saint-Gobain demo, and you can either click on import data on the top while you're still in the building materials page and say import Excel or GBXML file, or you can also go to the project page. Sorry about that. And go to sorry for that, and go to the projects that we just created. Yep, that one. So you can go back to the project level and say import Excel or GBXML for this specific design actually that you're looking at. So once you click on that, you can choose the file, and I will need to find that. It should be in the downloads, and it should be that. And if I continue on that, you then get exactly the same pages as you got with the Revit import. So the process from now on is exactly the same. You have to choose the project and the design you want to add it, either the baseline or a new design if you're working on different iterations, for example, and you want to keep track. The tool that you want to use, filtering all data, let's say, and replace. I'm gonna just go and replace everything in this case. Again, the grouping rules, there's not much to group in this case, so I'll just continue. And in this case, similar with Revit, you get the identified data and the problematic data, which is not the case now because it has managed to identify all the materials that we imported. And this is because you can see here, all of those materials were previously marked by either myself or colleagues of mine. And this is because basically we use this sample file quite a lot in software demonstrations, so the software now remembers all those selections. Normally for you, all these, not many of these materials actually will be empty at the first time, so you should go and find a suitable mapping, and once this is done, you can click continue, and that is it. It will take you back to the results page where you can check the results, and if needed, you can go back to the building materials page to change any of those or any other page, really, like the energy consumption I see here is being highlighted. I'm not gonna go through the energy tab. Just very quickly select something and add some energy. But yeah, this was covered in the previous session. I think that was it, and right on time for 10 minutes actually allowance for any questions if there is any. I'm gonna check the chat again. Yep.
Do not hesitate, yes, to raise your hand even.
Yeah, feel free to speak up or just
Yep.
write your questions or comments on the chat by all means. I will take that as no questions.
Seems it was crystal clear. Anyway, it has been recorded, so you'll be able to digest the training if you want.
Okay. I guess some last comments actually. If you have any questions after this session, feel free to get in touch with your teacher first, because they might be getting the same questions from other students as well. Actually, sorry, as a first step, please do visit our help center, because most of the stuff can be resolved through one of the articles. If it's not there, get in touch with your teachers. If your teachers don't know the answer, they will contact our support team, and we will get back to you as soon as possible.
Thank you, Marius.
Thank you, Eric. Thank you, everyone, for attending.
Okay. Keep in touch then. Good luck with the use of OneClick LCA and with all your project. Can you explain
actually, there is
the
a
results?
Comment. Yeah, explain the results. Yes, of course. I think we covered this in the first session, but I mean, we definitely have enough time to go through the results. So let's go back to the results page. So here, actually, we've got a summary of the results, different indicators in this direction, and different modules in this direction. So most probably you will be looking mainly in the global warming potential, which is basically the embodied carbon. And then you can read like the results by module if you want to use it as a hotspot analysis to see where most of the impacts are, which will always be, not always, in most cases will be the construction materials, say 1 to A3. But also you can get the total number. So this is your total number of global warming potential impacts. And further down, actually, there is something quite useful to check, is the completeness and plausibility checker. So this will actually give you some warnings on, certain things that might be missing or might be off. In this case, it tells you that there are some categories that are not present, and this is because we didn't actually model a full building LCA. And then there is a list actually of other checks that the software didn't pass, let's say. So there are several things that we're looking at, like mortar mass, glass mass on a per square meter basis. You can always check actually the unit that we're looking at. So for example, for the glass and opening mass, it should be like between 2 and 25 kilograms per square meter of building. In this case, it was a very small amount. So it basically gives you like a warning. It doesn't mean that if it is a warning, it is there is a mistake, but it's like a message to tell you that something is slightly seems off actually. So you can review on your own. If you're happy with what you did, you can always self-validate it so that you stop getting this warning. And then there are other rules here that pass the quality check. And then as you scroll down, you see several other graphs, like the impacts, global warming impacts per module, per classification code, because we use the levels classification system by resource type, but there is a series of different graphs here. We can simply select the all graphs, and you get like all the graphs that you can that you have available. So these are here actually to help you with a hotspot analysis. This is not quite representative. So in an embodied carbon assessment, you probably not have any electricity, so you could get like the different material types that contribute the most. But after electricity, for example, you should go and check the foundation concrete and concrete in floors and asphalt and rebars and glass wool and so on. We've got Saint-Gobain diagrams, tree maps. So it works exactly the same way. The concept is that you get visually a very quick glance of of the impacts and what is causing most of them. The time series chart that we saw during the presentation and several others as well. So this is one of the results you get. You can also get the total results on the project level in the project page. So you get like the results for this option, but this will make more sense actually if you have more than one options modeled. So if let's very quickly create a copy of that design. You will see now a different design being populated, exactly the same impacts, but once you start doing changes here, you will see these graphs starting to change. Again, you will most probably be looking into the global warming potential, but there are some other indicators as well. And there are so many different graphs as well to help you actually do a comparison by classification system, classification code again, and module, and so on. And I see there is another question. Where can we find the PowerPoint presentation from first and second session? The first session, I think I
So yes, for the first session, I shared them by email on Monday actually. But anyway, you'll be able to get the replay in video plus the PowerPoint presentation on the website, Architecture Student Contest website, very soon.
Yeah, and we
will
of course do the same thing for this for today's session together with
sure.
the exercises you do them. Yeah. Oh, I see that you already actually applied to that, Eric.
Yes.
Okay. Any other comment or question? Anyone? Yeah.
Okay. Thank you very much again, Marius, and to all of you for participating.
Thank you very much.
Good luck with your project.
Yeah. Yeah. Good luck, everyone.
Bye-bye.
Bye.
Take care.
Thank you.